Hello and welcome to another presentation on the AW139 Interactive Systems Trainer. This is the last one and I'm just going to be speaking about performance charts. In helicopters it's very performance chart intensive and all of them are incorporated into the respective RFM of the aircraft, and you generally have to look up these charts, enter them with a ruler and a pencil and come out with some numbers. And I find it a lot easier just to put the charts into Excel, such as the height velocity chart here for the AW139, which anyone who flies that 139 will be familiar with. And it's simply a matter of, so the inputs are pressure, attitude, OAT and gross weight, and you can change them just by clicking on these buttons here. So OAT 12 degrees, gross weight, you can make bold changes by clicking here, and you get the answer that you're looking for. Okay, which makes it a lot, as I said, anyone who has used these charts will know how painful they can be. This makes it a lot easier. I've only got one chart for the 139, but the previous aircraft I flew, the S92, I have a bunch of charts for that aircraft. So here's the category A rejected and continued takeoff distance. Again, pressure, attitude, temperature, unfactored headwinds and TDP are the inputs. Just click on the arrows here. See the temperatures over on this scale. Unfactored headwind. You can change it by ones by clicking here, or by fives clicking here. And TDP. We always used to use 45 TDP, but it is a variable TDP, so you can change it here and you'll see TDPs on this scale. And you'll get your answer. So rejected and continued takeoff distance in feet and meters, 513 for these inputs. What else have I got? The maximum takeoff and landing gross weight. We used to use this just to work out our maximum takeoff gross weight for the pressure, altitude and current temperature. And we'll see, well, it was always a much lower pressure altitude. We used to take off from sea level. It might be something like this. 34 degrees, so your gross weight is reduced to 11.6 tonne essentially. The 50 feet rate of climb at LSALT, we used to work out for our Cat A calculations. Okay, pressure, attitude, temp, rate of climb, we used to leave it at 0.5. Pressure, attitude, that's the pressure altitude at your LSALT. The temperature at your LSALT, and your maximum takeoff mass to be able to maintain that rate of climb at that pressure, altitude and that temperature. The best rate of climb speed works as well, so as you make changes here, that speed will change, so you know what your best rate of climb speed is. I go to the front page of this. Okay, so all aircraft have performance charts which look very similar to this. So these are your cruise performance charts in the S92 RFM. There are a lot of these. So this is 8,000 feet. You see ISA plus 10, ISA plus 20, ISA plus 30 for 8,000, 10,000. 12, anyway, it goes all the way. You can see how many charts there are. They're numerous. Can I just see if I can zoom in? Okay, it's just to zoom in on one chart. So normally, if you wanted to look up your performance for the aircraft, you'd open up this chart to the. Okay, that's 0. Let's go to one that might be a little bit more realistic. Okay, 4,000 feet plus 10. So you might be cruising at 4,000 feet pressure altitude with ISA plus 10. You'd enter here to find out what your max endurance, long range, continuous cruise, continuous torque available, etc. If you've got your gear down, what your delta torque is. There's a whole bunch of information you can get from this chart. Quite tedious to get it though. And again, if you're cruising at something that's not exactly this, at 4,000 feet and plus 10, then it's not going to be accurate. It'll be accurate for the purposes of flying, but not super accurate. Okay, so in here, what I've done, I've essentially put all those charts into Excel. So this is the 10,000 foot pressure altitude at ISA, 10,000 ISA, minus 10, minus 20, minus 30, and it just goes on. I've got pretty much all of them up to 10,000 feet anyway. I didn't put anything above 10,000 feet. So if we go back to the front page, how this works, you'd work out what the pressure altitude you're going to cruise at. So let's say you're cruising at 6,250. The temperature at that cruising altitude might be ISA plus, say, 18. Your maximum takeoff weight, so 22,000 pounds. And this is just for, we used to work on 140 knots TAS for our cruising. And this TAS planning here will give you all the information based on that TAS and these numbers here. So let's just say you want to plan 145 knots TAS, which is probably not quite achievable. We'll leave it at 140. So what it does, it works out, so it interpolates. So essentially you want to look at the, it's between 6,000 and 8,000 of the two charts. So 6,000 temperature of ISA plus 18. So you have the 6,000 ISA plus 10, 6,000 ISA plus 20, the 8,000 ISA plus 10, and 8,000 ISA plus 20. So it's going to be somewhere in between these four charts. So you move up one iteration, you'll see it's interpolated between the temperature. So it interpolates between these two to get this number, these numbers, sorry. And it interpolates between these two charts to get the ISA plus 18. So obviously 18 is somewhere in between 10 and 20. And these are the numbers that it gets. And then once again, the altitude the pressure altitude you're cruising at is in between these two, 6,000 and 8,000. So it interpolates again. And it gives you the numbers for 6,250 pressure altitude and 18 degrees, your ISA plus or minus number. So at 140 knots TAS, you expect an indicator of 124. You need to pull a torque of 60, and your fuel flow will be 1,196 pounds per hour. So your max endurance numbers, your long range numbers, your max speed AEO numbers, your OEI max speed, OEI minimum speeds, and your gear down. So if you happen to have your gear down, this is the penalties. Obviously your fuel flow is going to be a little bit more, you have to pull a bit more torque to get the same TAS and indicated. So as you can see, this makes it a whole lot simpler to work out your performance than actually going into these charts here and working it out. I mean, and then if you want to interpolate, you'd have to go into 2 or 3 charts and do all the interpolations yourself. But this does it automatically. You can see on these charts. Okay, so your max range. These work out your max range numbers. This works out your cruise numbers based on your weights. These are your weight lines: 22,000, 26,000, etc. And all the numbers come out onto this front page. Anyway, I hope you found that useful. It is just to show you what you can put into Excel. It is quite handy. Just one other thing I'll point out. Note this is I've done these charts in 2 different ways. These charts here are just using Excel wholly, and these lines and the grids are all from Excel. On here, however, I've cut the actual chart out of the RFM. There is an Excel graph behind here, but the chart is overlaid. So this looks exactly like the chart you'd find in the RFM. Okay, and that completes the presentation on performance charts. I hope you enjoyed it. Thank you.